Subtraction, as it turns out, is very, very much like addition, just in reverse. So some people say they're opposite operations. If you want to be nerdy about it, you'd say inverse. But I don't think you want to be that nerdy. So either way, what we need, again, is we need to be able to memorize the subtraction facts from 0 to 9. There's not as many as there are with addition because order does matter with subtraction. And then, yeah, they're going to give us several different strategies for subtraction. Hopefully one sticks, okay? So hopefully you find one that you're like, you know what, I really like that one, and then I will do that. Some students like, I don't like any of them, and I get that too. So that's understandable. But I can use fact families to check my subtraction with addition. Fact families, they sound more nice than they are, but we'll see. For these types of specific words, well, subtract, it's not supposed to be that redundant, but you may see it, okay? Minus is another way to subtract. I don't know what the relationship is there or why it is that way, but minus happens. And then difference is kind of like the result of a subtraction problem. So if you did 2 minus 1, well, I'll do 3 minus 2 is 1. 1 is your actual difference. But difference tells us that we are using the subtraction. We're using subtraction operation. And then another way we may see it is, it's like you're taking something and removing it, right? Like I had to have a tooth removed, so I subtracted a tooth from my mouth. I don't miss it either because it was in a lot of pain, but you know what I'm saying? Or you take stuff away. So it's like when your wardrobe gets too many clothes and you got to take stuff to Savers or DI or whatever you take it to, and then you take them away, right? You're subtracting, or then maybe sometimes you just lose it. But the one that really sticks with me is spending, because I really like money. So I don't have much of it either, which is the cruel irony there. But spending, right? If we think about this in spending, sometimes, especially in college, it makes more sense if we look at it in terms of money, because then the words tend to make more sense. I say that because subtraction, order does matter, and if we do it wrong, well, we get it wrong, and we don't want that. Okay, so we do want to make mistakes right now. That's good, but we don't want to always be making the same mistakes. So here we come back to the finger thing with subtraction now, though, and we can use fingers to subtract. So please do it. And the good news for us right now is that we're only dealing with positive numbers, so we're never going to take away more than what we start with, right? So again, going back to the money thing, we're not going to look into debt. But in addition to that, you're not going to get down to 0 with your fingers and then have more to take away to get into the negative. So the negative thing, I think it happens, but I don't think it happens till module 4. So I'll show this 2 ways with the hands, and I guess I could have done that with the addition part, but there's my hand. So I would say, look, I'm going to start with 9, and then I'm going to use 4 fingers to take away from 9. Now this means that I have to know how to count backwards. If you don't know how to do that, just practice, okay? It's not a big deal if you don't know how to do it, but we do need to get used to it, especially if we're going to use fingers right here, okay? So I'd say there's 9, so I'm going to put 4 fingers up, but that's what I'm taking away. I'm counting backwards. 9, 8, 7, 6, and there's 4 fingers that ends at 5. So 9 minus 4 would then be 5 total. Or what you can do, since we're dealing with single-digit numbers, so here's 2 hands now. I feel like my drawings got worse there. But you could put 9 fingers up. I don't have the thumb on the right hand there, but whatever. But now we would take 4 fingers out, and then that would be our final result, right? So I take 1, oh crap, 2, 3, 4. Almost pretty much lost that hand right there. Whatever. Either way, you end up with 5 fingers up, which is still the same result, okay? Now this, it may not seem that profound, but again, I still use my fingers when I do some counting. In fact, I just did during the break. But since right now we're not looking to go into the negatives, in fact, I guess we may do some borrowing, but even then, I'm thinking specifically about this method. We shouldn't be taking more than 9 away, which means that all you need is 10 fingers, and you should be able to really, you could have lost a finger by now and then still be able to do the subtraction that we're going to be doing with your fingers, okay? That we want you to have down. Again, notice that it cuts off here, because if I start doing 9 minus 1 at this point, then I get it, sorry, not, what am I looking at? This would be 8, I should be looking down here. Like if I did 8 minus 9, then it'd be negatives because I'd be taking too much away. And we can see this would end up going in the negatives. 8, 7, 6, 5, 4, 3, 2, 1, 0. And then the only way to make that smaller is if this number gets bigger, but by these numbers getting bigger, the total or the difference goes downwards. See that? So we have our addition facts that we would like to memorize, but if we can memorize also these subtraction facts, again, the nice thing is that we can understand other things better because we're able to do things faster, right? Now, are we saying that you can't use your fingers? No, that's not what we're saying. Please use your fingers if that's what helps you. But eventually, we want you to have enough practice where it's like 7 minus 3 is 4, boom. 5 minus 2 is 3. 4 minus 1 is 3. That kind of thing, right? So you can just kind of spout them off as people tell them to you, and then maybe someday you'd make a really good Jeopardy contestant. So here's another example. Let's give ourselves two numbers. Okay, 6 minus 4, that's how that would read. Or, I shouldn't be reading these now, but you could say this, and this is where it gets weird with subtraction. This is 4 subtracted from 6. If you wanted to, it's up to you how you want to read that. 6 minus 4 is the most direct way that I can think of, though. Now, again, if you have your facts memorized, you just say 6 minus 4 is 2. Other than this, you may have to use your fingers, which is fine. Or if you wanted to refer to the chart, you could until you get used to this, but I found it right there, 6 minus 4. Notice that this chart does not include 4 minus 6 because then you'd be taking away too much. And the first number, for now, has to be bigger than the second number so that we can actually figure out what this value is. Once we start subtracting with values 10 or bigger, then we start stacking them again. Now this one would work for what we're doing. Because again, we should, right now, the first number is always what you start with, right? So again, I like to think about this in money, because I like money so much. In fact, I like it so much, I'm gonna use green. So it'd be like saying you got $2,647. Now, why would you subtract $531? Maybe you spent it, maybe you paid your bills, maybe you lost it, meaning, I don't know, in the stock market or something, who knows? But there'd be subtraction, okay? So you'd be losing 531 bucks. This is nice, but we won't always be able to think about this in money. If it does help you to put, by the way, just what I did right there, sometimes students are like, let me go back. Okay, so right here, students are like, I don't understand what the crap is going on. And then we say, okay, well, what if we do this? And then it's like, oh, I know how to do that. Okay, now. Yeah, it helps. I don't know why. Like if maybe you guys like money that much, because I do. But if it helps, put dollar signs next to stuff. I don't mind. Just we want you to be able to do it, okay? But once again, we see, even without the expanded form stuff, that we're just going to line up the numbers by place value, right? So 2,640 and 7. Again, there's my thousands, hundreds, tens, and ones. And then 531, 500s, 3 tens, 1, 1. And then we can subtract these by place value, starting with the place value furthest to the right, which is always going to be the ones for now. And then we would subtract 7 minus 1. And then we just go to the left as we continue to subtract. All right, so we need 4 one-digit numbers. Okay, so let's go ahead and subtract these. Again, I'm just going to line these up by place value. I've only got tens and ones. So I've got 7 tens and 6 ones with 76. Getting a little bit of separation there to give me some space to work if needed. And we're going to subtract 24. That's 2 tens and 4 ones. But again, I've lined these up by their place values. Ones and then tens. Well, let's go ahead and subtract these. So we just focus on the place value furthest to the right, which is the ones. And kind of like we showed with addition, you can show the subtraction right here just so that you can remember, even if it helps. We're just doing 6 minus 4. There are the tens, we just don't care about them right now. We just want to focus on our ones. So 6 minus 4, you could use your fingers, right? So 6, 5, 4, 3, 2. There's 4 fingers up, so I ended 2. 6 minus 4 must be 2. Okay, so then we're going to pull this over. Now we're in the tens. 7 minus 2, so 7, 6, 5. I almost went the wrong way there. But yeah, we're subtracting. So that ends up being 52 when we subtract 76 minus 24. Now to go back to what we're talking about with difference, this is the difference between 76 and 24. Meaning if you had $24 but wanted to get up to $76, you'd need an extra 52. Because it's a difference. It's the distance between the two values. That's another way to say it. All right, so as it turns out, it's possible that we may need to do some borrowing. So when we're taking away too much, we have to borrow from the next place value, meaning the place value to the left, like kind of like this one shows, right? Again, why are we putting money symbols here? Because we know we can take money and actually split it up into different denominations, right? So you could take 100, and just for the sake of this, for our place value system, you take 100, you take 9 tens, and then you take 10 ones. That still totals $100, right? But if you're going to take $7 away, now you can take 7 of the ones out, which is what we're doing here. And what would you be left with? From the 10 $1 bills, you took 7 out, so you'd have 3 $1 bills, and then the extra 9 tens that you kept. So you end up having a total of $93. Now, yes, you could have a $50 bill and stuff like that. But again, the nice thing about tens and ones is it stays true with our place value system. So that's why we're using that. The main idea here is that you can take bigger bills and split them up into smaller ones. That's the main headline here, okay? And that's all borrowing is going to be. I don't know. I may show it a couple different ways, but let's take some numbers and start subtracting. There we go. That's better. Took us a little time, but we made it. So I got to subtract these, right? Now here's what I'm going to do. I'm going to show this with the expanded form because hopefully the expanded form will help us with the with just the regular stacking. Okay. So I've got 54,321. So that'd be 50,000, 4,000, 300, 20, and 1. Right? And we're going to subtract from that 9,000. There's 9,000, 800, 800s, 7 tens, that's 70, and then a 6. This is all subtraction, and we can literally subtract each of these as we go. But again, these are numbers that end in zeros, so that makes that fairly convenient for us. But the problem is, since we will start as far to the right as we can go here, which is just showing as 1 minus 6, the problem right here is that I'm taking away more than what I have to start with. Okay, so I've got to actually look now into my tens place value. And since the 1 is the value that's too small to take the 6 away, I would not be borrowing from the 70. I would be borrowing from the 20 because that's where the 1 came from. It's from the 21 up here. So what I'm going to do is I'm going to take 20. Remember, we talked about this too. Math is what we want it to be, not what the math wants to be. So I'm going to force it to do what I want it to do, and so that I can start working with these numbers in a little bit better way. I'm going to take 20, and I'm going to split it up into 2 tens. Now, again, that does not change the value. It just changes the way that it looks. So there's the 10, but the other 10 I'm going to lend or let the ones borrow from it. Now, instead of this being a 1, it's an 11, and I now have enough to take away the 6, right? So 11 minus 6, you'd say 11 minus 6, 11, 10, 9, 8, 7, 6, 5. So that ends up being a 5 right there. And that is because we borrowed 10. This used to be 20, right? There's still 2 tens, but I let 10 of one of the 10s go into the ones. Now that we've completed the ones, let's cover those up. I'll keep the 5 so we can actually see that difference there. So now I'm in my tens, but even before we borrowed the 10 into the ones, it was too small, right? We used to have 20 minus 70, but 70 is too big to take away 20 away. So what I need now is I've got to look into the next place value. Oh, there's 10 tens right there. There's actually 30 tens. If I can just borrow one of those 10 tens, I'll rephrase that into a 100. So again, I'm going to take 300 And instead of showing it as 300, I'm now going to show it as 200, but I'm going to give an extra 100 over to my tens place value. Here, now I'm still focused on my tens, so I've got 11 tens minus 7 tens. So 11 minus 7, 11, 10, 9, 8, 7, 6, 5, 4. So that ends up being 4 tens, that's 40. Now we're on to the hundreds place value. But again, the hundreds, even before we borrowed, still no good. So I got to borrow from my thousands. So I'm going to take that 4,000 and I'm going to split it up. I'm going to keep 3 of them in the thousands place value. But I'm going to lend one of the thousands over to the hundreds place value so that now I have enough hundreds to take away 800. And now, in the hundreds, so some people like to tack on the zeros first, but 12 minus 8, 12, 11, 10, 9, 8, 7, 6, 5, 4. So that'd be 4 hundreds that are left over there. And yeah, we already borrowed from the thousands, but again, that's too small. So we got to look now into the 10,000s there. I should have covered this other garbage up. I don't know why it's doing that. Technology. Okay, so I got 5 of my 10,000s, or 50 of the thousands. I'm going to split that up now into 40,000s by giving one of the 10,000s over to the thousands, which now makes 13,000 minus 9,000. And so in thousands, 13 minus 9, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4. So that ends up being 4,000 there. Oh, and then we got the 40,000 that just drops. I think I wrote those down correct. So we have our differences for each place value, and it's in expanded form, so to change it back, we got in our ones, we got a 5, we got 4 tens, 4 hundreds, 4 thousands, and 4 10,000s. So that's it right there. Let's do this, but with a regular stack. So I got 54, I need more space on those. 54,321, that should do it. And then we're going to subtract 9,876. So let's get to subtracting then. All right, by place value, we start with the ones still, but the idea remains the same. So let's get that stuff covered up. But I'll start with just, I'm going to keep it like this, okay? Now I am just focused on the 1 and 6. I'm keeping the 2 and 7 because I'm already expecting to borrow, which we will need to do one way or the other. So this is the way it's usually shown when we do borrowing, okay? So the 2 tens, we would say, you know what, I'm going to make that 1 10, but I'm going to give one of the tens over into the ones place value like this. Okay, now you see it's still showing 11 minus 6, which is what we want. And 11 minus 6 is still 5. Okay, so I'm not going to do the counting because we've already done the work there. But as I move over to the left here, what I have now is 1 minus 7. But again, that's not enough. So what we do is we say I'm going to borrow from the hundreds now into the tens. So the 3, I'm going to take one away and then make this, instead of 1, I'm going to make it an 11. Okay, so then again, 11 minus 7. This is how many tens there are. There would have been 4 tens. Make that the same color. There we go. Okay, so moving to the left still. Now I have 2 hundreds minus 8 hundreds. But again, 2 hundreds is too small. I'm going to have to borrow one from the 4 and make that a 12. 12 hundreds. 12 hundreds minus 8 hundreds. Again, we still know is 4. And then further, again, 3 minus 9. It's not, 9 is too big to take 3 away, to take away from 3 rather. And so I'm going to take the 5 of the 10,000s, move one over into the thousands. Now it's 13,000 minus 9,000, which is still 4. And then the 4 10,000s we just drop. Because there's nothing to subtract, we get the same answer. But again, this work is shown a little different, but the idea is still the same. You're borrowing from the next bigger place value in order to make this subtraction work with each specific place value. Borrowing and subtraction when we get zeros like this one, Sometimes we can't just look into the next place value. We actually have to look in the next two place values. And here's what I mean by that. So the stacking of 801 minus 64, we've already stacked it like this. The problem is, if we look at this, I got 1 minus 4, right? I can't do 1 minus 4. It's too much to take away from 1. So then I would look to the next place value, but there's nothing to borrow there. There are no tens to borrow. Well, technically there are, it's actually 80 tens. Okay, so here's the way that I would want you to look at this. It's not 0, it's 80. It's 80 tens right there. I'm going to borrow not from the 0, but from the 80. And now, if I borrow 1 away from the 80, I take 1 down and I get 79. And then I can make that 11 minus 4. And that's what this is showing on this part right here. Okay. Is this still the same value as 801? Yeah, it is. 791 plus an extra 10, that would still make 801. Right? I have not changed the overall value, but I did change the way it looks. And, well, that's kind of nasty looking, but it's still doable, right? Here we can say 11 minus 4, I'll just do this quickly, but 7, 9 minus 6 is 3, and then just drop the 7, boom. So we end up with 737. Again, we can show it here, 11 minus 4, there's the 7. 9 minus 6 is 3, drop the 7, bam, same answer. But this is borrowing with zeros, and it wouldn't matter. Let's say there was another 0 here. I may have to borrow from 3 place values, 3 more place values. Then I would look at it like 800, and then borrowing 1 down would make it 799. See what I'm saying? So you look over until you can borrow. If there's zeros, you can't borrow from 0. There's nothing there. Got to keep going over to the left. All right, there we go. 70,603 minus 6,897. You guys try it out. See how you do, then we'll go over it. All right, let's stack this, see how everyone did. We got 70,603. If you're wondering why we didn't get to choose these values, because we want to see the borrowing as 0, so I had to make sure it's going to work. As you've seen, when I do it off the top of my head, it doesn't always work. So 6,800, 9 tens, 7 ones. Now we are ready to subtract. All right, so starting in the ones place value, once again, we see that it's a problem. We're taking away 7, but we're starting with 3. It's taking away too much. So we're going to borrow from the tens. Oh, problem again, right? Remember the 0 thing. So there's nothing to borrow in the tens. Now, there is the 9 in purple there. I don't care about that. That's in the number that we're subtracting away. So I'm just going to look at the red number. Now I would look at this not as 0 tens, but 60 tens. And if I take 1 away from it, okay, so I'm going to take 1 away, that would make it 59. And then I would have 13. So 60, again, the counting down thing, at least with the borrowing, we shouldn't have to count down more than once. But 60 minus the 1 ends up with, again, this is how many tens there are. There's 59 tens instead of 60. Now, it's still 60 total tens because we got the 59 and then the extra 1 would make 60. So now we've got 13 minus 7, which would be 6. And now in the tens, 9 minus 9, we can do that. That's 0. So no borrowing there needed. And then, okay, so in the hundreds place value, though, we got the 5 minus 8. Yep, we're going to have to borrow there. But again, and this happened on purpose, we got a 0. So I can't borrow from 0, so I got to look even further over. And again, I would look at that as 70. I'm going to borrow 1 out of the 70 and make that 69. And then I'm going to make this in hundreds. I got 15 hundreds. Now, once again, if I take the 69 and the 1, if I were to combine those, it would give me the 70,000 that is there. But we're using it the way we want to use it instead. Now I got 15 minus 8, which is 7. Okay, so now we're in the thousands place value. 9 minus 6 is 3. And then the 6 there in the 10,000s just drops. If you like your commas, feel free to put that in. And that's it. Kind of a crappy boxing in, but I'm okay with it. The good news is that there is a relationship with subtraction and addition, and that's what we get these fact family stuff, okay? So this is abstract, meaning that the letters will eventually represent numbers. And all of these would be true statements So if like this, if it was 5 minus 1 is 4, you could do 5 minus 4 is 1, is what that's saying. Or if you wanted to do 4 plus 1, you'd get 5. That's what we're saying. So you can replace the letters with numbers. It does need to be true, so I would not put in this, I wouldn't say 7 minus 3 is 25. That would be false. And then you would start out false, and then the fact family becomes a false family. That sounds bad. So what we're going to do is we're going to take the subtraction problems and then change them into addition with these fact families. So maybe it'd be good to copy them. Okay, so here's our fact families. We got our place values lined up over here. We're going to subtract 92 minus 67, then we'll check this with addition. So 92 minus 67. So here's the way this works. I'm going to say on this one that because I've got an A, B, and C, I'm going to say, well, C has to be the first value in the subtraction problem. So C is going to be in my 92. And then the 67, it doesn't matter if you say it's A or B. I'm going to say it's A, though. So A is going to be 67. Okay, now right now it's a subtraction problem. In order for this to be an addition problem, which is what we want, and we see that it's A plus B equals C. Now, where's the B? It's not being shown. It is there, though. It's just not being shown. We're going to show it as a question mark right there because we don't want to see letters in here yet. So as an addition problem, it would be, so it's A, that's the 67. And then the B, again, that's what we don't know yet. I'll make that green. And then this would equal the C value, which is 92. Now that may be enough for you to do the subtraction without actually having to subtract. Some of you may understand that addition better. That's how we're going to check the addition. So let me copy that down here. In fact, I'll keep that blank for now. Okay, so this is how it sets up for addition. Once we solve our subtraction problem, because we can solve it directly, right? Like this whole stuff, we didn't really need this until later on, but that's how it sets up. So let's set up our subtraction problem, okay? So we got the 92. And we're going to subtract, that's what it was in the beginning, we're going to subtract 67. Okay, so with our subtraction, in the ones place value, I've got 2 minus 7, but 7 is too big to take away 2 from 2. And so I'm going to borrow from the 9 there and make that 8. So now I've got 12 minus 7, which would be 5, in the ones place value, and in the tens place value, 8 minus 6 is 2. Now this means, assuming we've done this correct, which I believe we have, that if I were to replace the question mark with 25, it should be true. So it says to check with addition. Okay, well, 67 plus 25 should be 92, right? Now I just kind of set that up because of the fact family, but I'm going to take that value, 67 and 25, and I'm actually going to add them together because it's going to be so fun. And 7 plus 5 is going to be 12. There, carry the 1 over there. 1 plus 6 is 7, but the extra 2 makes that 9. 92. And so it does check off. So there's my check mark. And we now know that 92 minus 67 is 25. So this is a nice way for us to be able to actually check answers on not just an assignment, but a test or a quiz. I don't know if we have any quizzes, but tests at least, all right? So this is a way to guarantee it. Be aware as well, on some tests they're going to say, you know what, you have to check with addition. So we have to have this down, not just because it's on the assignment, but they may put it on the test. If you didn't have 15 minus 2 memorized, decompose the subtraction, and that should help us to rewrite in 2 different ways. So what I think they want on this, because again, there's lots of different answers that we'll accept, is if we were to take 15 and just separate it, okay? Again, there'd be kind of like expanded form. It'd be like 10 plus 5 here. And then we would say, you know what, go ahead and subtract those 2. What this allows us to do is just focus on the 5 minus 2 right there. Now, it's not asking us to solve it, right? It just wants us to rewrite it in 2 different ways. Now, what that does for us is 5 minus 2 is 3. And then if you keep the 10 plus 3, it's still in expanded form, which then you can simplify just to 13, right? So even though 13 is the result, that's not really what you'd put into the box. Okay, so that's one way, which guess I kind of boxed in the wrong value, but that's one way that I would say that this would work. Let's try this one. Let's try this one, okay? So I'm going to keep 15 separated in its expanded form, meaning 10 plus 5. But I'm going to separate the 2, in fact, okay? So instead of subtracting 2, again, why would this help? I don't know. But instead of showing this as minus 2, I'm going to show it as minus 1, but then I'd have to subtract another 1. Okay, maybe subtracting 1 is helpful for you. I don't know. But again, it kind of decomposes those numbers. Does it make it easier? I don't know. But they asked for 2 different ways, and so that's what I did right there. That's what we get. Now, again, the assignment would accept so many other different ways, but that's what I got. Write 3 different ways to, write 3 different ways? Find 3 different ways. Typing's hard for Sal. But find 3 different ways to write 26 as a subtraction of 2 whole numbers. Okay, now I'm going to give you one because I'm generous like that. But it's also the easiest one. Sorry if that doesn't work very well. But what I like to do is I like to take the number and just subtract 0. Boom. That works because anything minus 0 is itself. Okay? So that's pretty good. But you guys see if you can, what do they want? 3 different ways? See if you can come up with 2 other ways, all right? So many to choose from, only 3 that we've written, including the one that we started with. Hey, that works. So not only did we do 3, we went the extra mile and did 4. Maybe you can think of others, and you would have fun doing this. But you'll have to do it on your own time. All right, subtracting with number lines. Subtraction moves to the left on the number line. So, like I said, when we went over this with addition, the steps are exactly the same because we don't know if we're going to be adding or subtracting depending on the assignment, right? This one, of course, is subtraction. And subtraction tells us we're going to move to the left on the number line because this would be like taking numbers away or going down in value. So in a subtraction problem, the first number tells you where to start, and that's the first, this bottom dot, I guess. You just slide it over to whichever value it is, and then this one tells you how far to go, and if it's subtraction, the direction is to the left, and then you can count off however many it's subtracting, okay? Again, do not expect any values to go in the negatives. You may see the number line go into the negatives on the assignment. It should not have negative values as your answers, though, which I think is pretty convenient. Okay, so 9 minus 5, if we were to see this on the assignment, again, I would have to take my bottom dot right here, I'll make it red, and I would have to slide it over to 5. I'll slide this over to 5 right there, and when I do that, it will create an arrow. Well, it'll be straighter than that on the assignment. Sometimes technology makes this worse. Okay, so, and that will slide the top one over as well, okay? Let's see, do that one in purple, and that'll move that one too. So it's going to start over there, and then, oh crap, I went over to 5. There we go. I need to move it over to 9. That's better. Okay, so we're going to see if I can do well, I won't say that's better, but it's different. So, yeah, so that's there, and then they're going to have that other dot above it. Since it's minus, so we already found where we started. We started at 9. The minus tells us that we got to go to the left, and the 5 tells us how far. So I'm going to take that dot, and I'm going to move it over left 5. So there's 1, 2, 3, 4, and 5, and I end at 4, which means that the actual subtraction here would result into a difference of 4. Boom. On the assignment, they'll have an extra arrow like this. So it'll look something like this. Next up, we got inverse property of subtraction. Anything minus itself is 0. That's really all we're saying with this. We've already seen anything minus 0 is itself, but now anything minus itself is 0. So 13 minus 13, again, if you start with something, but you're taking the same thing away, automatically you're gonna have 0 on there, okay? And I think this was on our chart of subtraction facts that we would like you to know. Maybe it wasn't. This is a old school, traditional math fact. I wouldn't say it's a principle. It's a nice math fact, though. So on the assignment, they're going to have these blanks they got to fill in. This would be 0. So 70 minus what is going to be 0? Well, in order for this to result in 0, you'd have to take 70 away from itself. So 70 minus 70, and that would be, both of those would then be true. All right, subtraction with rounding, which we like, because if we round, it means we have to do less subtracting by place value, right? So on this one, where it says we're going to do front end rounding, that's the front end. We got to look at the number furthest to the left. And so we're going to start, I would start with the 8,370. Since I'm needing to round it to the front end, I don't have to think about where the place value is or even what place value it is. I see I would round with the 8, which is in the thousands place value. To the right is a 3. So since it's less than 5, the 3 to the right of it, the 8 will stay the same. And then I will end up with 8,000. Again, this means that 8,370 is closer to 8,000 than it is to 9,000. And then the second number, 5,886. It seems like we've seen these numbers, but either way, the 5 again is in the thousands place value. If there were more values to the left, I would have to go there, but the 8 to the right is 5 or more, so I'd have to add 1 to the 5, making this a 6,000. So again, it is closer to 6,000 than it is to 5,000. Now we will subtract these, but 0 minus 0 is still 0. But 8 minus 6 is 2. With the front end rounding, we end up with a difference of 2,000. So here's the values we've come up with. Let's estimate the difference by rounding to the nearest 100. Take a minute, try this one out, then we'll go over it. Well, let's get it done with then. So let's start with our 6,073. And again, we're going to round this to the nearest 100. The hundreds is the 0, and immediately to the right is a 7. So I've got to add 1 to the 0, which is going to make that, it would make it 100. But again, don't forget your 6 in the thousands place value. So that rounds 6,073, which is closer to 6,100 than it is to 6,000. And then we look at the 3,706. And rounding this one to the 100, the 7 is in the hundreds place value. Immediately to the right is a 0, meaning that it will stay the same, 700. But again, don't forget your 3 there. So now we're ready to do our subtraction. 0 minus 0, 0, 0 minus 0, 0. The 1 minus 7, I'm going to have to make that 11, so I'm going to borrow from the 6. 11 minus 7 is going to be 4. 5 minus 3 is 2. So we end up with a rounded value of 2,400. So hopefully we feel pretty good. Maybe we haven't memorized the subtraction facts from 0 to 9, but hopefully we feel pretty good about subtracting, even if we got to borrow, and then maybe even changing some subtraction to addition to check our answers.